In this week, we're going to learn how to create low-res meshes and generate all the maps needed to transfer our high-res assets into Unreal Engine. And there is two things that we need to prepare for the engine. First, we need to create a low-res mesh from the high res that we have, and then any data loss between the low res in the conversion process from high res into low res, we're gonna store that into into maps. We're gonna create tangent maps, we're gonna create normal maps, we're gonna create point position maps, and we're gonna learn how to extract all these maps using Mantra. And then we're going to go through a variety of assets that each presents a different challenge, primarily how to create procedural UV coordinate for the meshes. And then once we prepare all the data, we're going to create low res, bake all the maps, and then go to Unreal Engine and import all the data, shade the assets, and then create a simple environment and then light it. So let's get started. So this is our first asset that we want to generate a low res for and start baking it. And I have a high res mesh here that doesn't have any geometry inside. And the first thing I'm going to do is generate a low res version for this. Now Houdini 16 has a poly reduced node, but this has been improved drastically in 16.5, which is what I'm using currently. And this is the version I have. You don't have to use this version. You can still use Houdini 16 and get the same result. So let me create a poly reduce. The main feature for the poly reduce, the algorithm is better, and it also inherits the attributes which it didn't use to do before. So what I'm going to do is, let's say, how much we have 1.6 million. So I'm going to use 1% of this. Because of the game engine limitation, we always wanted to keep the poly count very reasonable and very low. And in this case, I think I'm keeping it per asset below 20,000 polygons, if possible less. Obviously, each engine, and depends on how much you have in the environment, will have a limit, a polygon limit that you have to respect. And in some cases, there is simply not enough polygons that you can pass to the engine, so you have to basically reduce the quality and sacrifice a lot of details. But hopefully with the normal maps and the tangent maps, we're going to be able to capture that. So this is the low res version. And I think it's actually, I think it's very low. So I'm going to go to, right now it's only 8,000. So I'm going to increase that to 2%. Yeah. Cool. And then the idea is we want to create a UV coordinate for this. So for this guy, what I'm going to do is I'm going to create a seam that travels along this path. Each geometry has its own limitation, and for this one, because of the way it's laid out, I'm going to create a seam, an edge loop that travels through it, and then use that to unflatten the geometry. So I'm going to create a group node, and I'm going to change it to points, and I'm going to select one point. I'm going to select one here. Let's display this as flat shaded. Yeah, that's good. I'm going to call this start. Let's copy this. Call this end 1. I'm going to select another point that is at this corner. Okay, I'm going to copy this. And I'm going to call it end 2. And I'm going to select another point in this corner. I'm going to copy it one more time, and we need another point in here. So I'm going to call this N3. Cool. This may not be perfect at this point, but we're going to try and create the edge loop with. So what I'm going to do is I'm going to use the find shortest path node. And this guy You basically give it a start and end point, and it will try to find the shortest paths that connect both of them. So in the start group, I'm going to say start 1 and then end 1. And there we go. We have our first edge loop. And if we template the geometry, you can see it's connecting those two. Now the next thing is I'm going to select this point and this point here. So I'm going to copy this node, and that will be N3 or N2. Yeah, and then we have another edge loop. So we're going to continue. We're going to connect this guy with this guy, which is called N2 and N3. Okay, we're going to do another one from this to this, and I can't remember the number, but let's see. Yeah, so N3 and N1. You can probably name these corners A, B, C, D better to make more sense. And then what I'm going to do is I'm going to create a group for each of these guys. So I'm going to group all the edges, and I'm going to call them edges. I'm going to do the same thing for all of them. I want to make a group with all these guys. I can probably do it afterwards. So let's merge them all. And let's create a group. Cool. And I'm going to give this color, this group a red color. I'll explain why in a second. So right now we have an edge that represents all the points and edge loop around the geometry. And I'm going to use, I'm going to create another color here on the original mesh. And I want to copy that information. So whatever is in here, I want to copy the points, that color back into the mesh. Okay. And the easiest way to do this is to create a point attribute on these points and use that to transfer the attribute back. So what I'm going to do is I'm going to come in here and create a wrangle node. And let's say I'm going to store the original point number. So I'm going to call it original ID, or original ptnum is equal at ptnum. So we're just making a copy of the point number and storing it as original ptnum. Now if we once we create the curves, it's going to inherit that attribute. And you can see it there. Now we can copy the attribute from here, from here into here. And the attribute that we want to copy is the CD, and we want to match by this guy. Let's see. Original point. Sorry, we're not inheriting the attribute. So what we need to do is we need to do one more thing. We need inside the this guy. You see this attribute here? We need to change that with the name of the attribute that we have, so that with the newly created geometry inherits that. And instead of changing this value, I'm going to simply change the name of my attribute so it inherits that correctly with the information that it needs. And now if we see, we have the correct value, and that's what I'm going to use to copy. Cool. And now we've transferred the color from these curves into the mesh. And the next thing we need to do is we need to group anything that has that color. So I'm going to create a group node. Actually, I'm going to create a group expression. And I'm going to say group anything where the red channel is higher than 0.5. And I'm going to set it to points. And now it's grouping all the points around that edge. I'm going to call these point edge. And the next thing we need to convert this from points into an actual edge loop. And to do that, there is a very handy feature in the group node called Group Promote. And this allows you to promote a group type from point to primitive, or from point to edge, or from edge to point, and things like that. So I'm going to promote the point groups to edge. Let's call them final edge. And in the conversion process, we need to tell it from point to edges. But you can see it's taking extra edges into account, and we don't want that. We just want the parts in the middle. So we're going to tick on include only elements entirely connected. And we have our edge loop. Cool. So the next part is to create the UV coordinate based on that. So we ended up creating an edge loop around our geometry, and that's what we're going to use to run the pelt or the UV unwarp on this mesh. Now, I probably should have covered the various methods available, but I think by the end of these 3 examples that I'm going to be showing, you guys will have a very clear understanding of the nodes available in Houdini to do UVs. And what we need to do now is we need to basically select anything beyond this edge. Select all the primitives beyond this edge and select all the others on the other side, and run a UV pelt, which will easily unwarp this mesh and give us a good result. So what we need to do is we need to split the mesh in 2. We need to separate these 2 blocks. And to do that, I'm going to use a edge cusp node. And this guy, you can give it an edge loop, a group of edges, and you will separate along that. So I'm going to select that final edge. And now we should have, if I select primitives, we should have 2 groups. Perfect. Now I'm going to blast each one of them by hand. Just select, double click, remove that, and then do the inverse. And I'm going to use a UV pelt node to generate the UV for each piece individually. And let's go to the UV editor by hitting space 5. And this is the result that it's giving me right now. I'm going to change this to barycentric, and I'm going to increase the iteration to 2500, and then the boundary springs to 100. And this will give me a perfect, almost a perfect mesh. It may have some overlaps, but all in all, I think it's going to be enough for what we need. Now we can tweak this by hand, but I'm not going to worry too much. The space that we're losing here is not that big, and it should be enough because we only have 1 asset. Now I'm going to do the same thing for the other, and this is the result that we have. Cool. And then I'm going to merge the 2 together, and then fuse the mesh back again. Why is it turning out? Okay, that's good. Let me change a value to force it to cook again. Not sure what's happening here. Okay, yep, it's working now. So fusing that, and now both of them are overlapped on top of each other. Now I'm going to use a node called UV layout that will lay out these 2 pieces together. Now probably we want to scale them and rotate them so they each cover a specific part, or cover more space of in the UV coordinate, but I'm not going to worry too much about that. I can add a transform, a UV edit node here. We can scale them like that, or maybe 2 And let's see what we get. So to create something like that to cover more space, but I'm not gonna do that. This should give me a good result already. Cool. So let's take a look. And this is our mesh. Let's remove the color information, and let's put down a UV quick shade. Now this part is, it may show some distortion, but this is not going to be an issue for us because we only need this information to use for the baking, and then the bake will generate a correct result based on this UV coordinate. For the texturing part, we're going to use the what's called the planar. Can't remember the name in Unreal, but basically it uses the normal to create a UV coordinate. So we're going to use that to apply the diffuse texture, and then plug in all our maps using this. Now I think we're done. We have the UV coordinate, we have the color information and everything needed, and all we have to do is prepare the bake between the high res, which is this guy, and the low res. So let me create a null here, and I'm gonna put down a file cache. I want to cache this result because it takes a few seconds to compute. Okay, one frame. All right, I'm gonna call this out high res, and I'm gonna call this, the other guy, out low res. Gonna create an object merge, import the two guys, and then we're gonna do the same thing for this. Okay, cool. So I'm gonna copy them, and I'm gonna hide this guy. I'm gonna create a new one, call this high res, paste in the high res version. Let's cut this and create another one, call this low res. And now we're going to prepare the baking between the two guys. So now we have our high res mesh and we have our low res version. They are both overlapping on top of each other. And we're going to use the low res to basically capture any details available in the high res version and store that into a text file, a texture file. Pardon me. And for that, we're going to use Mantra texture baking, and the node is called bake texture. It's not called Mantra, but under the hood it uses Mantra. So this node has pretty much all the options. The default are generally fine. There is few options that we need to change for Unreal baking. And what I'm going to do is I'm going to tick on all these extra maps. And by default, it uses the RAD format, which is Houdini native format. And this allows for multi-layered channels. So it can store multiple things into one file, but we need to extract them into individual files. And this is where we can do that. Now, the next thing we want is we need to specify the objects, the low res first, and then the high res. The UV cage option is a mesh that you can provide to tell the low res object which direction it takes to look up for the high res version. So we can use, for example, we can take this and create a peak, add a peak node and push it along the normals. So we have another silhouette, another cage that tells these points what direction they need to move along. I've never used this, but in some cases it may be useful. So the next thing we need is under baking, we have to tick this use MICT tangent space. This is what Unreal requires. If you don't have that, you're not going to get the correct result. I'm going to leave everything as the default, and then these are the important features. important techniques for baking. There is UV to surface, there is trace closest surface, and UV match. UV to surface basically takes the UV coordinate and tries to locate the closest surface based on that. This is not going to work because our high-res mesh does not have any UV coordinate available on it. So we're going to use trace closest because that's the only thing we can use at the moment. We can tell for this point, do a lookup and see which one is the closest to you, and then give me the result based on that. So I'm going to lower this to 512. And then under rendering, we're going to leave that to the default. For the final quality, we may have to increase this to 8x8 or 6x6. And then I'd like to always specify the object in case my scene gets messy. So I'm going to tell it to force those two things together. And then I'm going to hit render to unplay. Now it's going to take a few seconds for it to export the mesh, and it will start rendering. Cool, it's done. Now we can see the UVs that we've ticked on, these guys. Occlusion, displacement, thickness, normals, vector displacement, tangent, curvature, cavities, and curvature. Now if we look at these two guys, we see this looks good. It looks like it's capturing all the details, but these guys, the vector displacement and the vector displacement tangent, they don't look correct to me. And the reason for that is because we are using this lookup technique that will take this point and then basically open a dome on that point and see which one is closer to it and trace against that. But some points are behind it, and this technique does not work well with that. So what we need to do is we need to use the UV match technique, and this basically requires a high res, the UV coordinate on the high res to match perfectly the low res. And in order for us to provide that, we have to go back to the original mesh, which is this guy, and unwarp this, which is a nightmare. This is really pretty much impossible to create a perfect UV for this. And we can only do it on low res, on simple geometry. But then how can we make a high res that has the UV coordinate on it? Well, we can do this. I'm going to copy the low res. I'm going to call this low res to high res. And let me make a copy of this as well. I'm going to give it a different color. And I'm going to paste the high-res version. And what I'm going to do is I'm going to take this low-res version, I'm going to subdivide it. I'm going to subdivide it 3 times. And this will get me to the ballpark where this high-res mesh is. So 1.6, and now we're at 1.57. Cool. So now we don't have any details. Look at this versus this. We don't have any details in there. But we can use a ray node to tell these points to find the nearest neighbor from this and use that to and snap to it. So if the default settings will give you this. Let me create a null. So the default settings will give you this, but it's working, it's capturing details. And what I'm going to do is inside the ray node, I'm going to change it to minimum distance. And now it's gonna give me much better result. So this is the original one, and this is the low res with the ray node. But the main advantage is that now we have a UV coordinate, and this is very helpful. Let me make a small change quickly. Okay, and what I'm going to do is I'm going to call this out high res phase 2. I'm going to call this high res phase 2. And we don't want to compute the difference between this original high-res, the original high-res and the low-res. We want to compute it between the new high-res and the low-res. Okay? Why is this displaying 2 copies? Okay, there is a glitch in the viewport. Cool. There's still a glitch in the viewport. No, sorry. So this is the new high-res, and this is the low-res. And both of them have UV coordinate on them. So I'm going to go back here and change this from UV to surface, from trace closest surface to UV match. Let's hit render. And there we go. Hold on a second. Sorry, yeah, it's not, we didn't specify that yet. So let me change a few things. I'm going to change the high-res version, and here I'm going to change this this guy as well. And let's render. And there we go. Now we're capturing perfectly the surface and all its details. And this method is going to work really well for all the other fields as well. Now, what I'm going to do is I'm going to change the settings to 24 to 2K for all of them, and I'm going to increase this to 6. And I'm going to hit render, and we'll have the data ready for this asset. So the bake is done, and these are the image, the result. This is the cavity information, this is the occlusion, this is the normals, and this is the vector displacement. Now, this is not something that we're going to be using in Unreal. We're going to be primarily using the normals, but I wanted to show how to get proper baking if we needed the vector displacement, and just to be sure that our system is working. Cool. So now we have our first asset ready, and we're going to move to a different asset and see how we're going to prepare it for Unreal. We're going to continue now and look at how we're going to create a low-res version of this and generate UV coordinate for it. And this is a very, very tricky asset to work with. You can see there's a lot of cavity, there's a lot of intricate details. We're going to be sacrificing some details in order to be able to pass this to engine, especially with these intricate overlaps. But all in all, we're going to have something that resembles and looks very similar to this. Now, the main issue with this is we don't have a clean mesh. Let me show the wireframe. So everything is triangulated. Pardon me. We can use the poly reduce on this, but I want to show something different. And what I'm going to do is I'm going to use a Vdb from Polygon and actually convert this, pardon me, convert this into an SDF. So I'm going to set this to 0.05 and let's see what we get. This will create a volume out of that. And this way, I'm going to be able to generate a low-res version that has quads, because anything that we do with VDBs is going to be converted into quads. So if we convert this into polygon, we're going to have a perfect quad mesh. And this is much cleaner than the previous result. Now, the poly reduce will not give us results similar to this. It will give us a triangulated version of that. Now, we've sacrificed a lot of details with this conversion, we especially with these peaks, but it's the low-res conversion. There is not so much that we can do. And the fact that we have a quad mesh is going to be very helpful for us. Now, we saw in the previous video how we can use the find shortest path to select an edge loop along a geometry and use that and split it in 2 parts. But for this one, it's much more intricate. We have a lot of cavities, and that method is simply not going to work. So we're going to have to use something different. And what the idea that I come up with is to split this geometry into multiple sections. And I'm going to use a Vdb from Polygon. I'll explain why in a second. I'm going to create a density field, and let's fill the interior. I'm going to scatter some points, and let's say 10. And I'm going to use a node called cluster points. And this guy, we can give it a set of points. Actually, we don't have to feed it anything. By default, it will run a Voronoi-like algorithm to basically group each block individually. And the idea is I'm going to select the difference, the edge that is between these clusters. Each one of them, I'm going to select it and separate the parts and use that edge to unflatten the mesh. But this clustering is not working well. I don't like the way it's separating the mesh. So I'm going to create my own points and use them. I can scatter some points randomly. Let's see. Should work with this. Sorry, cluster, not cluster points. We need to use a cluster. The cluster points uses its own inputs. So with the cluster, we can use our own points, but then we need to view the cluster. So I'm going to use a color node, set it to primitive. Let's see, set it to points, and then random from attribute. And the attribute name is cluster. And now we have a clustering based on these points. We can lower that, we can increase, we can lower it, and now we have three main blocks, 1, 2, 3, and we can separate each one of them and deal with it. So basically, we have a big problem. We're gonna reduce it into a much smaller problem that we can solve, and this is what the clustering idea is. But right now I don't like the points that we have. So what I'm going to do is I need a grid-like points. So I'm gonna create a box and then connect that to the input geometry. And I'm gonna change this to points. I'm not gonna use polygon. I'm gonna change it to points. And now I can specify how much points I want per axis. And this is going to allow me to better control this, and I will have a straight lines which are more interesting to cut along versus something randomized. Cool. So I'm gonna lower this to 3, and I spend quite a bit of time trying to figure out the best points and the best layout. And in this example, I found 3, 3, 3 here, and then I need to add a transform node to scale the points along the z-axis. Sorry, along the y-axis. So we have even further splitting. Each geometry will present its own challenges, and once I show you guys the entire workflow, you will be able to understand what you need to do to get the good result. And what I ended up doing is looking at the UV result and playing with these values. But right now I'm using the existing settings. Cool. So what I'm going to do next is I'm going to loop over each cluster. But first, let me remove one cluster. So let's say cluster equal 1. Let's see, points. Yeah, so that's one cluster. And we can go through all of them. And each time we're dealing with one cluster. And what I want is we want to unwarp this mesh by itself. We want to loop over each cluster and then unwarp them individually. And what I'm going to do is to properly do that, I'm going to create a selection between where the clusters meet, an edge selection where each of these clusters meet. And to do that, we need to use a for each loop. So I'm going to create a for each loop. And that's good. And then we need to pass it the attribute that we need to loop over. In this case, we're going to use cluster. But right now, we want to loop over primitive, but it's a point attribute. So we need to promote that. So I'm going to promote the cluster from primitive to points. I'm going to set the method to maximum, so it only gives me, it doesn't blend the result between the clusters, between the neighbors. Okay, let's take a look. We should see one cluster. Primitive to point, points to primitive. Okay, and now we should see one cluster. Cool. Let me verify something really quick. Looks good. Yeah, so it's working as expected. And we have one cluster. And the next thing I want to do is I'm gonna select all the points along the boundaries of this. So I'm gonna create a group node. And I'm gonna change it to points. I'm gonna call this edge points. And we're gonna use the uncharted edge feature. So I'm gonna tick that, and it should select all the points. Let me turn this off. I'm gonna select all the points along the boundaries. Cool, now we have that, and I'm gonna create an attribute on these points, and I'll explain why in a second. So I'm gonna put down a wrangle attribute, and I'm gonna call this I at edge. It's a boolean, and any point that has been grouped, we're gonna set the attribute to 1. And I'm gonna run it on the edge points only. Cool. And I want to initialize everything with 0 at first. So here, that edge group is gonna be equal to 0. And let's do it even before. So I'm gonna do it before we cluster and at this point. Cool, so now we have initialized the this guy to be 0 for all the points, and then any point that gets grouped is going to have that attribute. So let me remove the points with that attribute equal to 1. Edge. Cool, and now we have those points. The next thing is we need to copy this information back and use that to select the edges from the original geometry. But we need some more preparation for this. Right now there is some primitives that gets that didn't get deleted, so we need to remove those. I'm gonna use an add node, delete geometry by key points, and then let's do it here. And then we're deleting everything else. The next thing is I'm gonna set a color on these guys, and I'm gonna copy that color back into the mesh. But we need an attribute to use to be able to know where to copy them back to. And that attribute we're going to initialize here. So I'm gonna create I original pt is equal at pt num. So we're storing the point number in an attribute called original. Orig pt, and that should get inherited here, so we can use a copy attribute and copy them here from this guy. And we need to copy the color and match by original point. Cool. Let's set the color to black so we only isolate this, and now we have the clusters. The next thing is we need to group all the points along this. So I'm going to use a group node. And I'm going to say at cd.x is higher than 0.8. Select the points. I'm going to set it to points. And now we're grouping all of them. And we're now we're working on the original mesh, so nothing has changed. We're then going to group promote this. Group promote this guy, which we're going to call edge selection. I'm going to promote it from points into edges and include include elements entirely contained in original group. And now we have our edge selection. Perfect. Cool. Let's do some cleaning. I'm going to delete all the attributes. We don't need anything really. And I'm going to delete all these guys. Cool. And then we have this edge selection group that I'm going to use with a UV flatten node. And this guy works really well if you have a good seams, or actually let's call this seams. This is what I'm going to use them for. I'm going to use them with the UV flatten as the seam, and that basically will be used as a cut for this node to unwarp the mesh. Now let's take a look at the result. Cool. So now we have blocks separated and they're perfectly unwarped. We can run a UV relax node, UV smooth node on top of this. And maybe there's another one for, let's try a UV layout, which is this one is much better now in Houdini 16. It does a much better packing, and the coverage is, it produces a much better coverage than the previous node. Now I saw some overlap in one of the areas. And the only way to fix that is to either go in and split those two blocks into separate parts. I don't see it anymore. Yeah, I think it's fixed now. But something like this, for example, this is not a huge deal, but the only way I got this nice layout is to try different combinations of this. So what you need to do is you need to go back and play with the clustering points, try different clusters based on your geometry and see how that works, what kind of UV it gives you. Now Houdini 16.5 is much better when it comes to this process, and all my testings were done using 16 only, so already the result I'm getting even with the UV packing is way better than what I had before. So definitely use the newest version, and this is one way of creating UVs for this guy. Now we're going to continue and generate the maps for this geometry, and we have the low res. We're going to create a new high res version and generate the baking. So I'm gonna save some time and tell you guys that the baking is not gonna work well if we use this with the original geometry, because the original geometry doesn't have a UV, and the best baking method result we get is using the UV. So what I'm going to do is I'm going to create a null, call this out low res, pardon me, object merge this, and let's go up, let's hide this, low res, cool. And let's bring in the original mesh as well. So let's create a null. Out high res. Object merge this. And I'm not going to use this with the baking. I'm going to use a new mesh that we're going to create. Cool. Let's create a new one. Let's call this high res. And let's import the low res in here as well. So we're going to do the same thing. I'm going to subdivide it. Three times. Let's see how long it's going to take. It's a lot. Let's try 2 times only. Okay, cool. Yep, I think this should be fine. And I'm going to use a ray node. Same thing. And let's ray this guy. Minimum distance Let's create a null. And let's take a look at the result. Now, from far away, it's perfectly fine, but unfortunately, it's not going to be able to capture all these guys. We can do a few things to help improve the result. We can try some lifting to lift the rays too much. Let's try with the project ray and use normals. And instead of using the current direction, we're gonna actually, let's use that. I'm gonna use the maximum distance, which is here. Something like that. Try reverse rays. Maybe we can peek the geometry in just a tiny bit. See what we get. It's not gonna work. So here it's only shooting along one vector. And unfortunately, it's not going to be able to capture that. Yeah, I think this is better. It's jittering the rays. Let's try adding more rays, see if that helps the result. Sorry, I meant to set it to 8. But again, I know we're not going to be able to capture this. Even if we did capture them, the baking process is not going to be able to display this. It's simply not going to work with cavities. So our original asset is really high res. So let's set this to 0. Sorry, I'm going to pause and we'll continue in a second. So I'm going to set this back to minimum distance, and we're going to use this as it is. Now, the normal baking, I noticed that it generally works with the trace closest, but I wanted to get the system to work properly. And to be honest, from the distance, it's definitely fine for this asset. We're capturing a lot of details. So I'm going to call this high res, and I'm going to go up. And this is the low res, high res. We're going to go to the bake texture. And let's select the low res. Select the high res. I'm going to take all these guys on. I'm going to use this for Unreal. And I'm going to lower the resolution to 512. Force the two objects. And let's hit render. And it should be coming up shortly. Cool. Our occlusion baking working perfectly. Cool. So I'm gonna do one more thing. I'm gonna increase. I want to show you guys the result in the viewport. So I'm gonna increase this to 2K, and I'm gonna increase this to 8. And I only ticked on occlusion, so I'm gonna render this to disk, and then we'll continue and see the result. So I've ran the bake and turned on normals and occlusion and P position. I'm gonna revisit the list to see what else we can extract to use in Arnold and in Unreal. Sorry. So this is the point position, this is the occlusion, and these are the normals. You can see we're capturing a lot of cool details pretty much, and it's gonna look perfectly fine in the engine. Now I want to show one texture in the viewport, so I'm going to create a UV quick shade node, and I want to show the occlusion pass applied to the texture. So I'm going to load it in, and let's turn off, it's the flat shaded, cool. And this is the result of our occlusion baked onto a texture and applied. Cool. So in this video, we're going to look at how to work with this asset and how to create a low res version and bake the maps as well. So the first thing I'm going to do is we need to generate a low res version of this, and I'm going to use a Vdb, the Vdb Workflow. So I'm going to create a Vdb from Polygon for this one, and let's try and capture a lot of the details. Let's go 0.02. And let's convert this to a polygon. Cool. Yeah, and the poly count is reasonable as well, so we're going to use this. Cool. So what I'm going to do for this asset is find a path, find a edge selection that starts at the top and ends somewhere here. And I'm going to use this to basically be the seam or the cutter that I'm going to use to unflatten this geometry. So we're going to use the same idea, the find shortest path. And I'm going to create that. Find shortest path, and I'm going to select a couple of points at the top. Say 1, 2, something like that. And then I'm going to select a couple of points at the bottom as well. And this is just so we have different variations. Say this. And I'm gonna set, this node has various options for which point to use in the start and which point to use at the end. I'm gonna set it to start from any start to any end, to each end. So this way, one second. Yeah, so I'm gonna use this from each start to each end. And I wanna get all the variations that are possible using this combination. And from them, I'm gonna select the one that I like the most. And I think this one is very interesting, this guy. So let's see which one is that. I'm going to select it. Let's select the primitive. Yeah, I'm going to use that. It covers the entire mesh. And except these guys, all of them should be able to produce interesting results as well. So let's do that same workflow we did. I'm going to give this a color red. I'm going to give this a color of black, and let's create an attribute wrangle and store the point number before it gets passed to this guy. And I'm going to store them in the original origpt attribute. It's equal to point number. Cool. And then I'm going to copy that information back. So color and match by attribute. This is my attribute. Now we have the points selected, and we're going to group them using a group expression. At cd.x is higher than 0.1. I'm going to call this edge selection, and we want to group the points. Cool. Let's promote that group. And it's a point group. We want to promote it to edge. Actually, let's call this seams. And we want to include only these guys. Okay, so the next thing is we want to use this edge with a UV pelt node. And you can provide with the UV pelt, you can also provide a cutting selection, and that will help it to know how to unflatten the mesh. So I'm going to select the seams. I'm going to increase this to 3500. I'm going to increase this to 10. And there we go. Let's see if we can set this to 1. Let's increase this to 15. And try to cover up as much space as possible from this. Let's go 4500. I'm trying to relax the mesh. I think that's the highest number. And I'm going to put down a UV layout, and this will also help fit in the environment. And we have a 77%, which is not bad for this asset. Okay, cool. So now we have the UV created. Let me delete all the attributes that we don't need. So this guy. This is good. This we don't need now. This we don't need. And let's delete all the groups. Okay, so we have our mesh prepped. Let's call this out low res. Let's object merge this. And let's go up to the upper level. Let's create a geometry node, low res, import that here, and then let's prep the high res as well. Just gonna copy these two guys. I'm gonna call this out high res. I'm gonna create high res here. Okay, cool. So we have both of them, the low res and the high res. The high res has UV coordinate, and we're going to create the bake node. Let's bake texture. So select the low res, select the high res. As always, go under advanced, select these guys to be sure. And then for this method, I'm gonna change it to trace closest. And what I want to generate, actually let me verify this super quick. What I want to create is I want to extract the displacement, the DS, and I will explain why I want this in a second. The workflow for in order for us to get a perfect UV capture, a perfect bake, we want to use the UV match. But we saw that generating a high-res version each time represents a challenge with a ray swap. So I want to show how we can create a better raying algorithm or a better raying solution using the texture baking. So I'm going to run a first bake. I'm going to call this first bake. I'm going to run a first bake. I'm going to increase the resolution to 4K. And let's see. I'm going to extract them as a rat because I don't need, I'm not going to use this for the in-game, and I just want to extract displacement. I'm going to run this. So I have the displacement baked, and this is the result that we have. And the idea I want to do is to use this map to and displace this low-res geometry after subdividing it. And this way, we're going to have hopefully a much closer geometry to the original high-res, but yet we're going to have the UV coordinate kept. So I'm going to subdivide this 3 times, and you can increase this as high as you want. For now, actually, I'm going to set it to 2 so it's faster to work with. I'm going to create a point VOP. And here the first thing we want to do is we need to import the vertex attribute, which is the UV. So from the first input, I want to import the UV coordinate, and then I'm going to use that with a color map to read in the displacement map that we saved to disk. Let me connect this. So actually, sorry, we need to convert this into a float and connect the X and Y respectively. Cool. So let's connect this to the color and let's read in our map. And this is the name of the file. So actually it's not that visible. So let's make sure it's working. Let's multiply it by a huge number. Cool, so it's working perfectly. We're going to use this information to displace the mesh here. So we're going to use, we're going to take the normal and multiply it by the displacement map. So normals. Multiply that by the result here. And let me normalize the normal just to be sure. And we're going to add that to the point position. So because we want to displace them. Okay, let's turn this off. Let's take a look. Let's compute the normals again so we have proper result. Cool. And this is our result with the displacement map. Now, there is an issue that we're gonna fix quickly, which is this guy here. And that's because there is a nan, which is a non-identified pixel that goes into infinity. We're gonna simply clamp the displacement map between -1 and 1. And we don't need it to be a vector. So let's do it here. Okay, and we need only one value, so I'm going to convert that into a float. Cool. And the range goes from -1 to 1. Let's lower this. Let's try a tiny bit more, and it's fixed. Cool, so I'm gonna leave it at that. And then, and now we have a super high-res mesh that matches closely the high-res version, but it has a UV coordinate in it. So I'm gonna copy this. I'm gonna put them side by side. And now we can generate a much more accurate baking between the two because they share the same UV. Actually, don't have to merge them. And this is the result. Cool. So let's continue. Don't need this. I'm gonna call this null out high-res 2 or high-res phase 2. And then object merge that, and we're going to create a new one. Let's make sure we always display the low res correctly. Let's put a note. Always display this. And then here we're going to create a new high res. And it's going to be the high res phase 2, which is basically the low res displaced. Okay, we have the two now. We can go and let's go back here. Let's create a bake texture. Select the low res. Select the high res phase 2. Select both of these guys. Rendering, we're going to keep that. We're going to change the unwarping method to UV match. The bake, we're going to use the Mickey texture. Mickey texture tangents, and then here in the UDIM post process, we want to do a border expansion just to add few pixels around the texture, and this is only going to happen to the extracted textures. It's going to render first into a RAT format, and then it's going to post process them to expand the edges and add the and then save them as a target file. And I'm going to add these two guys now. And then we're going to have, after this, we're going to have the maps ready, and we should be able to go into Unreal and start importing them. In this video, we're going to learn how to import the assets into Unreal Engine. But before we do that, we need to export the meshes as an OBJ. So all we have to do is we need to make sure that we compute a normals. So compute the normals here, and then we need to save it as an OBJ file. So .obj is the format that we need to use. Cool. So the next thing we're going to open, this guy, which is the Unreal Engine desktop app. And once you have this, you can click on Unreal Engine, and it's going to take a few seconds to load the existing projects, and you will be able to create new ones, open existing ones, and things like that. Cool, so I have 3 projects already, and I'm going to create new ones. So I'm going to go under new, I'm going to use blank, I'm going to call this assets importing, and I'm going to create a new one. It's going to take a few seconds to prepare all the files. Cool. So by default, it has few things. It has these assets, and it has a some lighting, which is very cool. Now, in terms of UI, we're not going to be doing a lot of stuff. This menu here is what we use to create the default objects, cube, sphere, lights, and things like that. This is all your, this is everything that exists in the scene, and every time you select an object, it's going to show you all the available options for it. And here you can scale it, rotate it, and stuff like that. This UI by default is going to be tucked in, so it will look like this when you first open it. We're going to expand it, and this is where we're going to import our objects. So first we need to import the OBJ file. I'm going to select the low-res version of the asset. I'm going to scale it 100. I'm going to rotate it on the X 90 degree, and then import all, because otherwise it's going to have Z as up, or yeah, it's going to have Z axis as up, so it's going to be facing the Z, and we want it to be Y up, like Houdini. So it's going to take a few seconds, and then it's going to import the model, and this will only make it available here. It's not going to be available in the scene. It's just going to become available in the library. So all we have to do is drag and drop it, and there it is. We have our first mesh imported, and the next thing we need is we need to create a shader for this. So what I'm going to do is select the object from the outliner here, and then double click on the material, and this will open up the Unreal Material Editor, which looks like this. Cool. So by default, it's using this default map. I want to change that. Sorry, I meant to hit the save as. So I'm going to change that and call this Sharp Cliff Base Material. And we need to import a few things. And the 2 things that I'm interested in importing are the maps that we baked, and primarily the occlusion and normals. So these are the 2 things. I'm going to hit import. And if everything went well, Unreal will tell us that the normal map was, it picked up the normal map and it converted it to be used, and it told Unreal to be to use that as a normal map, because there is a difference in how it treats the maps. So all I'm going to do is I'm going to drag these guys, here. I'm going to connect the normals. And I'm going to hit save. I'm not going to connect this yet. Okay, let's move this out of the way. And here, right now, it's still pointing to that default material. So I'm going to change it to sharp cliff base, which is our new one. And there we go. We have our normal applied to the mesh, which looks really, really cool. And you can see there's tons and tons of details brought up from the Mantra baking. The next thing I want to do is I want to connect the occlusion. So what I'm going to do is I'm going to use this slot here and just drag the occlusion and hit save. And that should make it look darker and have more details. There we go. It now has a lot more details, and it's probably too dark, so we may have to tweak this a bit. So let's right click, type in blend. Let's see, what's the name? Let's add to it. I just want to lift the black value. Maybe let's multiply it then. No, multiply is not going to do it. Let's hit see the color and see what we have. Nothing there. None of these are color related. So let's see with the add. We can use the red channel only. And I'm gonna click here. I'm gonna right click, say promote to parameter, and that will give me a slider that I can use. So now we can add a color to this. If that worked. See if it changed something. I'll see what's the best way to add. But I was trying to lift the colors of the black here with the occlusion. I think it's doing something, but maybe not. Anyway, it's not too important at this point. The next thing I want to do is I want to add some specular and roughness, and I'm going to right click on these two attributes, click on promote, and that will give me a slider. So I'm going to set this to 1. And we should see some specular. Right now the roughness is 0, the default, so I'm gonna click that and increase it. Maybe too much, yeah, something like that. And you can see the specular showing up now. Let's click save. And it should become available. Yeah, and now we have specular. Cool, so what I'm going to do is I'm going to we can, in Unreal, you can shift and drag, sorry, Alt, yeah, Alt and drag, and that will, it will make a copy of the asset. So I'm going to make few copies using the Alt function. And I'm going to use the R key to scale this up and maybe rotate it like that. Okay, and let's see, let's create a grid plane. And let's scale it. I want to add a plane underneath the rocks. Cool. And then right now the lighting needs to be recomputed, and I think you guys saw the error as well. What this will do is Unreal has its own GI engine and its own occlusion engine as well. So it needs to build all the lighting map for that and then run it. So I'm gonna hit build Lighting quality, let's set it to medium. I'm gonna hit build. This shouldn't take too long, hopefully. Oh, that's fine, we can ignore that. It's doing the computation now, it's done. And let's hit play. And we should be able to navigate through this environment now. Cool. So the next part is to import all the other assets and do the same thing to them. Import the geometry, assign the normal map, assign the occlusion if we needed to, and then we're going to add some textures to all of them. So let's continue and import the next asset. So I'm going to import the low res standing cliff. This is the tall rock. I'm going to scale it 100 unit and rotate it 90 degree. Click on import all. It always takes a few seconds to process the mesh. Cool, so let's drag and drop this. Cool, let's scale it maybe 4 times. Yeah, something like that. And let's do the same thing. So I'm gonna double click here and we need to import the maps. So let's click and we need the occlusion and the normal display, the normals. And I think that's pretty much it. Let me check what's this. This is the diffuse, we don't need that. So these two guys. Okay, and let's drag this over here. Let's save it as standing rock. Base material. And we need the occlusion. Let's connect that. We need the normals. Let's connect that. And then I'm going to expose these two guys. Promote, promote. Roughness, I'm going to set it to 0.3. This guy I'm going to set to 1. And let's hit save. And let's assign this. So we called it standing rock base material. Sorry, I assigned it to the wrong piece. Cool. So you can see we have all the details brought back using the using the normal maps and the occlusion, which is very, very cool. So the next thing I want to do is I want to assign some textures, and I want to use something similar to the triplanar that we did in. It's basically a technique that will use the normals to generate a texture coordinate, and this is the map I'm going to use for all the assets. This is the diffuse map, and this technique, it's going to generate normals using UV texture using the normals. So things that are facing upward are going to have a different UVs versus the thing that are facing along the x-axis, the 3 different axes. So I'm going to import this texture that I just showed you guys. Cool, and then we can assign it directly, but I don't think it's going to look pretty on this asset because there is no proper, the UV coordinate that we have is circular and it does not make a lot of sense for this asset. It may work, but I think we need more control using the triplanar technique. So what's called the name for this under Unreal is called World Engine. Hold on. World Aligned Texture. Okay, then we're going to need 2 things. We need the texture object, which is another node that we need to create. So we can select this, right click and say convert to texture object. And this is going to convert it to something different. It's not a texture sample. These guys are a different type of nodes. And we're going to connect that here. And then I'm going to connect the XYZ texture to the base color. Now the result here may look odd, so we need to test it on the object. And the main important control is the texture size. So I'm going to right click and say promote parameter. And let me see. It should give us something better than that. Okay, so we need a scalar for this guy. So I created manually a scalar attribute, a scalar node, using the tab menu. Sorry, using the right click and then typing in scalar, and then we have the texture size. Now I can scale this, let's say 100, and that will start tiling it. Now we need to see this in Engine. So I'm gonna hit save. Cool, and let's see. We need to find a good spot, a good value for these guys. Say 50. Something like that may work for this asset. Cool. Yeah, I think this is good. And the next thing I want to do is I'm gonna use this texture to drive the specular as well. So I'm going to use a desaturation node, take this result and desaturate it completely, and then connect that into the specular. And that should be, yeah, you can see now it's the specular is based on that. We can also use a range node. So range node basically will take an input similar to how we use it in Houdini. Sorry, no, not this one. Come on. Sorry. Yeah, I can't remember the name of the node, so I'll have to look that up. But for now, we're gonna use this, and then I'm going to add a multiplier for the specular. So I'm gonna add a mult node. Okay, connect this, and then promote this guy, and now we have a specular multiplier on top of the texture. If we wanted to reduce that. We can also use something similar for the roughness if we wanted to, but for now I'm gonna just increase it to 0.5. I'm gonna hit save. And now we have our second asset ready, and it's looking really cool. Okay, the next part is I'm gonna copy these guys, and I'm gonna share them with the other node, with the other assets. And I have two more that I'm gonna import and have them all ready. And I think that's pretty much it for this week. The important part is to go through Houdini, prepare the assets, bake them, have at least 3 or 4 assets, shade them primarily using the same technique that I showed, normal maps, and some kind of diffuse texture on them. And then next week, we're going to create a layout using these 4 assets. The next one I'm going to import, I can show you guys. The next one is the cliff that I chose. So, you know what? I'm going to do this. I have a better idea. I'm going to open the project and show you what I'm going to be doing next. And I have a 680 GTX, so it's quite with 2 gigabytes of memory on this machine, so it's pretty old. Cool. So this is the comparison that I did this for CGraph to show with and without the maps applied. You can see them here, which is very cool. So this is the final result of the project. And the next two assets are this wall here that I'm going to import, and then that we did, and then the ground, which is basically, I don't remember if I did baking on it, but I believe I used the original geometry, and then we're going to create a layout similar to this. So get 3 assets: the ground, the sharp cliffs, and the circular item that you can use to block out the entire environment. And then we're going to and then generate low res for them, bake them, and we're going to create something like this in week 4. Thank you guys for watching, and see you next week.